And ready? Okay, so that was secondary math 1. A whole year was talking about linear functions. Secondary math 2 and a little bit of this year is talking about quadratic functions. That's the parent function x squared. Thank you so much. Okay, so that was a lot of what we talked about in secondary 2 and what we talked about this year. Okay, so in parentheses, we'll call that quadratic. Okay, then once we moved into this year, we're now talking about the parent function y equals x cubed. Okay, see how they're going different powers? First one was just to the first power, second one second power. Now we got a third power. This guy is called a cubic function. Okay, let's take it up a notch again. Next function we'll talk about today is x to the 4th power. Fun fact, this is called a quartic function. Gonna really impress your parents if you go home and tell them this. Okay, and then just a couple others that we've talked about. Let's say 2 to the x, so something to the x power, where your x is in the exponential spot, and that's why it's called an exponential. Kind of going into number 3's space, that's okay. An exponential function. And then our last one, which we actually haven't talked about, we're going to talk about it today. It's y equals the absolute value of x. Those two lines around the x mean absolute value of x. So in parentheses, write absolute value. Whole bunch of different functions that we have talked about, that we're going to talk about today. Okay, these are the parent functions. Okay, and what it means when we say parent is that nothing's been added onto it. It's very basic. Okay, x squared, x cubed, x to the 4th, exponential, absolute value of x. Nothing else fancy is added on there. Okay, so let's go ahead, let's rewind back to secondary math 1. Let's go to example number 1. Okay, answer me this. This actually is not a parent function because we have this 5/3 that's been added and this +2 that's been added. But tell me, what power is on my x? What's the invisible exponent attached to that x?
1.
1. Beautiful. So again, when the invisible exponent is 1, this guy is a linear function. Okay, you learned about him when you were freshmen, linear functions. Okay, if you guys remember, this linear function is written in what we call slope-intercept form, okay, which we love because we can easily identify the slope and the y-intercept. Okay, so remember, my slope is always right in front of the x, whatever's attached to my x. So for this function, what is my slope here? What's right in front of my x? Gabe, I know you know it.
I don't know.
Yes, you do. What's right in front of my x?
5/3.
5/3. Beautiful. That's my slope. Easy peasy. Okay, what's my y-intercept? What's the number that doesn't have an x attached? 2. 2. Beautiful. Okay, so let's remind ourselves how to graph these guys. Which one do you start with? The y-intercept or the slope? Do you remember? Take a guess. Kaylee? Y-intercept. Beautiful. That's what we start with. That is an actual point on your graph. So you're going to find +2 on your y-axis. That's this guy right here. There's +2. Booyah. There's a point. A y-intercept. Okay, now we use our slope to just count to our next points. Remember rise over run? Yeah, remember that? I taught all of you guys that. Okay, sweet. So let's see, we're gonna rise 5. 1, 2, 3, 4. Oops, don't have room to rise 5. That's okay. Let's go down 5 instead. 1, 2, 3, 4, 5. But now since I went down, I now have to go backwards. 3. 1, 2, 3. Booyah, there's my second point. Connect those guys with a straightish line. And boom, there's a linear function. It creates a straight line, hence the word linear. Cool. Okay, that was freshman math. Let's go ahead, look at number 2. Answer me this. Is this guy a parent function? Is there anything fancy added on to this x squared function?
No, it does y and x and 2 square.
Yep, so there's nothing fancy added, so this actually is a parent function. This is the original. Think the OG function, the parent function. Your parents are the OGs. Okay, so here's what we're gonna do when learning how to graph this, figuring out what coordinate points we want. Give yourself a little table. We've done this before. On the left side is your x, on the right side are your y's. Okay, now when giving yourself a table, you're just choosing numbers to input, meaning let's try these numbers. We're gonna plug them in and see what we get for y. Okay, well if I plug in -1, so that's gonna give me y equals -1 squared. I just plugged it in for x. That's what we're doing. Well, tell me, what is -1 times -1?
1.
Positive 1. So we get a positive 1 for y when we plugged in a -1. Okay, let's do the same thing for 0. Now I have y equals 0 squared. What is that going to be?
0.
0. So when we plugged in 0 for x, we actually got 0 for y. Okay, now let's do the same thing for positive 1. What is positive 1 squared?
1.
Just positive 1. Okay. These become our coordinate points, our parent function coordinate points. I would put like a huge star by these guys because these 3 coordinate points right here are going to help you the rest of the entire unit. Okay, if you can burn those guys into your memory, the rest of the unit is going to be smooth sailing. Okay, so let's go ahead and put it on our graph. So my first coordinate point is -1, 1. So x was -1, y is +1. Boom, there's my first point. Okay, my next coordinate point, 0, 0. Okay, well that's just right there in the middle, 0, 0. Okay, and my next point, +1, +1. So +1 for x, +1 for y. And there we go. Remember the quadratic is that U shape, so you just connect those with your U shape, arrows at the end, because yes, this does go on forever. But you're done. These are what we call the parent function points. Yeah, Eli?
Can you ever stop the arrows?
That has to do with what we call domain and range. And if the domain is restricted, then yes, you can stop the arrows. But we haven't talked about that, but that's a good question. Maybe we should talk about that later in the year. Okay, so like I said, these 3 coordinate points for the parent function, they're always right there. Okay? So now let's look at number 3. So now go back up. Yes, enjoy my homemade drawing, my homemade graph for number 3. Is this guy a parent function? Meaning nothing special added?
Yeah.
Yep, it's just x cubed. Nothing else added. It's a parent function point. So we want to graph this guy. So let's give ourselves a little table again. X and Y, just like on number 2. I like using the same 3 inputs every time because it gives us some negatives, gives us a negative, and gives us a 0, and it gives us a positive. So I like using the same 3 x's. -1, 0, 1. Okay, we're doing the same thing. We're plugging it in, seeing what we get out. So if I plug in -1 for my x up here, y equals -1 cubed. Careful here. what am I going to get with negative 1 cubed? Meaning negative 1 times negative 1 times negative 1.
Negative.
Negative 3.
Negative 1.
Not quite negative 3, it's going to be negative 1, right? If just two negative 1s, negative times a negative, gave me a positive 1, right? But if I multiply that by another negative 1, I get negative 1. Nice. So I plugged in negative 1, I got out negative 1. Okay, well, let's plug in 0. 0 is probably my favorite number.
0.
What is 0 cubed? It's a big fat 0. Love it. Love 0. Okay, and don't overthink this guy either. What is positive 1 cubed?
Positive 1.
Positive 1.
Oh, it's the same.
It kind of is the same. So again, these become our 3 parent function coordinate points. So let's go ahead and put them on my nice little drawn graph here. So my first coordinate point is negative 1, negative 1. So negative 1 for your x, down to negative 1 for your y, and boom, there's our first coordinate point. 0, 0, we love that coordinate point, just right in the middle. And 1, 1, meaning positive 1, positive 1. Now, here's where you have to be super, super careful. This looks like it would create a straight line if I connect them, correct? Correct. But this is not a linear function. It's a cubic function, which means it's a little curvy. Okay, the way cubic functions look is like that. Boom, there's your cubic parent function, the OG cubic function. Nice. Okay, next OG parent function. Nothing fancy added to this x to the 4th. It's parent function. So let's go ahead and find our parent function points. Give yourself your table again.
We need another table.
Another table. Give yourself your same x's. You could actually choose whatever numbers you wanted for x's. I just think these guys are probably the easiest to plug in. Okay, so let's go ahead and plug them in. I'll do that down here. So if I get y equals negative 1 to the 4th. What do you guys think? What is negative 1 to the 4th power? Let's do it together. Negative times a negative.
1.
Times a negative.
That's a 2.
That's a negative. But then times another negative.
It's a positive.
It's a
2.
positive 1. Okay, so whenever there's an even power, right? Same thing over here with squared. We plugged in a negative and got a positive. Same thing with our 4th power. When we plugged in a negative, we get a positive. Because the power is even. 2, 4 are even, so we get positives. Okay, next comes my favorite number. What is 0 to the 4th power? 0. And we like positive 1 too. What's positive 1 to the 4th power? It's just positive 1. Okay. Okay, so now, there's our parent function points. And you're going to be like, wait, Mrs. Campbell, these are the exact same parent function points as our quadratic function, our x squared. Yes, you're absolutely right. Let me show you how it's a little bit different though. Okay, let's put our parent function points on the graph. Negative 1 up to positive 1. Booyah. 0, 0. My graph is a little not even, but that's okay. 1, 1. Okay, same parent function points, but watch what a quartic or to the 4th power looks like. Choo, choo, choo.
That kind of looks like a truth.
It's kind of like a W looking thing. So yes, same parent function points. It's not quite that perfect U though. It's kind of like a little curvy, squiggly U. Beautiful, beautiful. How bored are we? Scale of 1 to 10. 10 being the boredest.
I know
I can tell. Okay. This is the last parent function we're going to talk about. And if you guys are totally dying, I will skip a few on the back. Don't worry. I know, you guys are dying on me today. Okay, so last parent function that we need to talk about. This is our absolute value of x. Okay, we haven't seen one of these guys. Okay, so it's a parent function. Nothing fancy added here. So again, just give yourself your table. X and y again. Give yourself your same 3 inputs, your same 3 x's. Okay. Now let's plug them in, see what we get here. Now, who can tell me what is the absolute value? What the heck does the absolute value even mean? You guys remember the rule with absolute value?
Yeah, I can't remember.
Think of it like this. Okay, this is what the absolute value actually means. Okay, in fact, I want to draw a little picture over here. Draw yourself this picture. Say that's a 0, 1, 2, -1, -2. Okay, so if I'm looking at -1, the absolute value is saying how far from 0 is -1. How far from 0 is -1? How many spaces? How far? Just 1. Boop. It's 1 space away from 0. Okay, let's do the absolute value of 0. How far from...
I'll ask this time. Do you happen to know where Mr. Barnes is? I'm so sorry.
No, but I can always send him a text if you want me to.
You know what? It's all good.
Okay. How far away from 0 is 0? How many spaces?
0.
0. It's right on 0. Okay, now my last one, how far away, how many jumps or spaces is +1 from 0? 1. So that's what we're actually talking about when it's asking for the absolute value. How far away from 0 are you? That's why you always get positives. You can never get a negative in an absolute value. Right? Memorizing that? Cool. Okay, so there are our 3 parent function points. Okay, let's go ahead and put them on my nice little drawn graph here. -1, +1, 0, 0, +1, +1. And again, you're going to say, wait a second, those are the exact same parent function points as my quadratic and my quartic. But here's how it looks different. With an absolute value, it is a straight V-looking thing. Yep. Not curvy, it's not a U, it is a straight V-looking graph.
So V.
Yep. Okay, before you flip over to the next page, how are we feeling about parent function points? Could you look at a picture of this and know it was a quadratic? Could you look at a picture of this and know it was cubic? Quartic? Absolute value? Because that's what you're going to have to do for your assignment. I will tell you your assignment today is actually like super easy. Super. Yeah, it's great. Okay, cool. Don't worry, I'm not going to kill you with boredom. Let's turn over. Let's be done.